Swayam Prabha. Digital India. Educated India.
In this lesson, we'll look at another example circuit, which is to synthesize a negative resistance using an op-amp. I'll say negative resistance using Miller effect. I'll explain what that is. Okay. Let's consider a non-inverting amplifier. If the input is Vi, the output will be kVi because of this resistance ratio. Okay, it's 1 plus the upper resistance divided by the lower resistance. Now, of course, in this condition, no current flows into the op-amp. Okay, so the input resistance of this circuit is infinity. Let me show the voltage source explicitly. Okay. And let's say I connect a resistance Rx between the input and output, and then I'll evaluate the resistance of this part of the circuit, that is to the right of this line, between these terminals here and ground. And we know how to evaluate the resistance of any linear circuit. We apply a test voltage, find the current that is flowing in, divide the voltage by the current to obtain the resistance. Okay. Now, the only current here is flowing through Rx. This node is at Vi, this node is at kVi. So, this current Ix is Vi minus kVi divided by Rx, which is Vi times 1 minus k divided by Rx. Okay. Now, you can see that this Ix will actually be negative because this k will be greater than 1. Okay. We will assume that k is more than 1 because we are making an amplifier of gain k. K is at least 1, and in this case we will choose k to be more than 1. So that this k minus 1 is a positive number. Okay. So, this Ix in this direction will be actually negative. So, the current in this direction Ix is Vi times minus k minus 1 by Rx, which is Vi divided by Rx by k minus 1 with a negative sign here. Okay. So, the resistance looking in here Ri, which is Vi by Ix, is nothing but minus Rx divided by k minus 1. So, this k minus 1 is a positive number and Rx is of course positive, it is a physical resistor. So, the input resistance of this circuit is negative. Okay. So, if you wanted to synthesize a negative resistance, this is how we would do it. This is an amplifier of gain k, and I connect some Rx. Then between this point and ground, I see a resistance which is minus Rx divided by k minus 1. And in this circuit, of course, k is more than 1. Okay. Now, this is quite easy, and it turns out this is a specific case of what is known as Miller effect. If you have an amplifier of gain k, okay, I use this symbol to mean this circuit, let's say ground is the reference terminal, and this is Vi, this is V naught equals kVi. This is nothing but a voltage controlled voltage source of gain k. So, if this is Vi, this will be k times Vi. If you connect a resistance between the input and the output of the amplifier Rx, let us assume that no current flows in here, like here it is an open circuit, no current flows in there, and the amount of current that flows in there would be Vi times 1 minus k divided by Rx, exactly what I evaluated for the other circuit. Okay. If you apply Vi here, the amount of current that flows in there is Vi times 1 minus k divided by Rx. This comes from simple Ohm's law. So, the looking in resistance, which is Vi divided by Ix, let me call this Ix, is the same formula as before. Okay. It is minus Rx divided by k minus 1 or Rx divided by 1 minus k. Okay. So, by connecting a resistance between the input and output of the amplifier, you have an input resistance which depends on the gain of the amplifier, and this is in general known as Miller effect. And also, depending on the gain value, there are a few possibilities. If k is more than 1, we see a negative resistance at the input, and if k is between 0 and 1, we see a positive resistance which is more than Rx, more than the resistor that you have in the circuit, and if k is smaller than 0, that is, if k is negative, then we have a positive resistance that is smaller than Rx. Okay. You can make a large resistance look like a small resistance by connecting it across an amplifier whose gain is negative. Okay. So, this is known as Miller effect, and it manifests itself in some circuits, and this is how you calculate the input resistance. Okay. The main point is that the input resistance is determined by the gain of the amplifier. So, you can think of many possibilities, such as if you have an electronically varying gain, you could also have an electronically varying resistance, and so on. And of course, the additional application is what I already showed you, how to make a negative resistance. Okay. It can also be used for realizing a very small resistance, and so on.